In this video, we're going over the memorization approach of house robber. So previously, we have gotten our TLE, or time limit exceeded, from our recursive approach. So we're going to optimize it using memorization. Let's go over the thought process. So the recursive approach is inefficient due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. Now, what do we need to cache? In each of the recursive call, we are trying to find the maximum amount of money at the current index I. This means we can cache I and money. Now let's go over the pseudocode. So we're going to create an array Memo to cache previously calculated results. So the indices represents I. Now we want to fill Memo with -1. This is to prevent the side case where we cannot gain any amount of money from our input array. So we're going to implement the top-down memorization approach. And then what parameters do we need? We still need our current index, the input array, and then we're going to pass in our cache. And then what's the base case? If I was out of bound, there are no more houses to rob, so the amount of money is equal to 0. Now if Memo I is not equal to -1, this means we have already calculated the results for the current index, so we're going to return the cache results. And then we're going to recursively find the amount of money if we rob the current house, which means we're going to skip the next house. And then we're going to recursively find the amount of money if we skip the current house, which basically just moving our current index to the next house. And then want to put the maximum amount of money between the two choices at the cache, and then we can return the result. Now what's the time and space complexity? For the time complexity, we get O of n, where n is the length of the input array. There are n possible states with I, and our space complexity, we get O of n plus O of n. The first one is our recursive call stack memory, and the second one is our Memo array. We can also add another time complexity because we fill our Memo with -1 in the beginning. So I'm going to say fill Memo with -1. Now let's go over the code. So we're going to create our Memo, which is our cache. And I'm going to fill it with -1. And then we're going to implement our top-down memorization approach, passing in our Memo. The first base case is if I is out of bound, there are no more houses to rob, so there are no more money, we return 0. The second one is Memo I not equal to -1. This means we have already calculated the result for the current index, so we can just return the results. And in this case, we have recursively find the amount of money if we rob the current house, which basically means skip the next house, and then increment by the amount of money that's in the current house. And then also if we skip the current house, and then before we return the result, we want to cache it. And then do not forget to pass in our Memo into other recursive calls. Let me know if any questions in the comment section below.